Let's continue. The next and very interesting part is BigSwitch networks, which is by far the simplest and easiest to implement solution. Did you know that BigSwitch came to life actually in 2007 as a science project in Stanford University? And right now it's being used by Microsoft in its data centers, by Tesla, and by Visa, which is the card that we use every day. So it's a huge step forward since 2007, and here I give it to you.
Thank you. I hope everybody can hear me fine. Hello, my name is Tomasz. I'm a representative of BigSwitch Networks, and I'm helping out here in the European region to promote our products, to explain to potential customers how they're working. So I'm more of a technical person. So any questions around technical stuff, feel free to interrupt anytime. If anything comes up, I'll be happy to answer them. All right, so as it was mentioned just right now, BigSwitch is more or less 10, 11 years old, and it did come up as a project at Stanford. Basically, the people who came up with the OpenFlow protocol, they basically invented the software-defined networking. OpenFlow, that's the protocol which created the base for this type of networking. The group of people who were working on that research project at Stanford, they split into a few teams later on. Some of those people went to Google and they started working on the biggest data centers in the world. Some other team went and started their own company called Nicira. Maybe some of you are aware that later on this company got acquired by VMware, and now this is the NSX product. And finally, the final part of the team, they started BigSwitch. So it's been over 10 years that we have been in this software-defined networking environment. And I'm sure you are seeing this transition happening towards software-defined data center, and this is what Emil has been talking about in his presentation. There are more and more things in your data center, so you want to optimize. You want to automate as many things as possible. You want to have better visibility into what's happening inside your data center, and you cannot do it with your traditional approaches. They just don't scale that well. So there are lots of new elements: software-defined compute, software-defined storage, software-defined networking is the element which binds it all together, which interconnects them all. And this is, again, the same slide which Emil has been showing. Yes, we have been recently noticed as one of the visionaries for data center networking. And the environment here is really good. We have Dell EMC and we have VMware as which are our partners. So this is one big ecosystem here, and we are all in the visionary bucket. Why are we doing software-defined networking? If you think about it, the legacy approach of doing networking, it's over. You can't scale with it. You can't automate too many things with it. And our marketing people came up with this slide showing you this analogy to driving your cars. Back in the day, those cars were really hardware focused, right? There were lots of elements you had to do manually. Now, if it kept on going this way, you would have so many different consoles on your car to configure every little piece of the engine, of everything which is under the hood. But that's not the case. This is not our car's look, because we have simple steering wheel, we have navigation, we have gear shift, we have pedals to accelerate. So what we do, we're not configuring those little elements of your car, you're expressing your intent. So this is the intent-based driving, intent-based activity. You want to go forward, or you want to go backwards, you want to go left, right, accelerate, or brake. So you just have simple controls to express it. In the future, or for some people already, we have autonomous cars, we have self-driving cars. there's more and more automation happening in the car industry. So the driver will be just clicking, okay, this is my destination, and the car takes care of the rest. So now when we take this approach into networking, this is where we come into the picture, and this is what we are trying to do. So now think about your networking in the legacy approach. You have multiple boxes in your data center, which you manage separately. Like each top of rack switch, you manage it separately. You have to configure similar elements on each and every of those boxes. When you make a mistake in a big data center, you have no idea where this mistake is, on which device you misconfigured something. And you spend days, maybe weeks, trying to troubleshoot some problem, why those two servers are not pinging. You have to go into each device and check, validate their configuration. You want to add a new VLAN spanning across your entire data center. Again, you need to touch each of those boxes separately. But now when you think, okay, we can do it differently. What if I could only express my intent? I want to provision a new network. I want to provision a new VLAN across my entire data center. I want to configure span sessions from all of my switches inside the data center. This is what we can help you do. This is what our products are doing. They're a way of managing your data center where you have single point of configuration, single point of visibility, single point of troubleshooting for your entire data center. And it doesn't need to be a big data center, because the smallest scales that we would support here is like 1 or 2 racks. This is where it already makes sense to install our solutions. But the biggest scale that we can support currently, that's 64 racks. That gives you 128 dual top-of-rack switches, which you manage from one point, which you manage from one console. You can, with one click, you can change configuration on all of those devices. Think how much time you're saving on this. There's lots of automations over here that we are implementing to make your life easier. For instance, if you are adding a new switch into your data center, you're basically building a new rack. You want to add two top-of-rack switches. In a traditional approach, okay, you need to rack them, then you need to log into each of those, bring them up, configure all of the networking configuration on each of those boxes. Maybe you can copy and paste. What you do with our approach, well, you take MAC address of each of those boxes of the management port, configure them at our controller, assign aliases, assign names to those switches, and within 5 minutes, those devices are ready to work. They have full configuration, and they can start forwarding traffic. So again, we're saving you time. And there are lots of this type of automations. I hope I will touch most of them during the later part of my presentation. And finally, as with self-driving cars, we are trying to implement more and more intelligence in our network. We're working on some machine learning ideas. We're thinking of doing some service devices for the data center inside our fabric, again, managed from the same point of configuration, just to make this network even more automated, maybe self-healing, self-provisioning. Is everything clear so far? If there are any questions, feel free to interrupt. So I hope by now you understand why we're trying to change the networking. Just because, well, the legacy approach, that's not going to work. And for that, we have come up with actually 2 products, which are supposed to be very easy to use, and as customers would tell you, as our partners would tell you, they really are. They are making your life easier, basically. First product, and this is our flagship product, this is Big Cloud Fabric, BCF. This is your data center networking fabric. Basically top-of-rack switches, plus the spine layer which interconnects those racks. And this product works perfectly well as your data center network standalone product, but we can integrate with solutions like VMware, OpenStack, containers, and as of recently, we are also adding hyper-converged infrastructure like Nutanix into the picture. So this is how we manage your production network traffic inside your data center. Our second product, called Big Monitoring Fabric, BMF, this is a solution focused more on the security side of your data center. It works in two modes. In the first mode, we help you monitor the traffic in your data center. We collect copies of your packets from your tabs and span ports and deliver them to your tools, to monitoring tools, performance tools, anything that needs to see copies of your packets. The second mode in which this product operates, it's inline. And over here, we help you secure the border of your data center. We help you do security chains for security devices on the ingress and egress of your data center. Next slide, I'm going to have it more visual, so hopefully it will all make sense. Both products use the same three principles. First of all, there's a controller which manages the entire solution. Single point of configuration, single point of contact for you. That's the only thing you will be touching in your data center. Then we have open networking hardware. Dell EMC is our biggest partner, and our cooperation is really working well. But just as a formality, I'm going to mention that this is the world of open networking. So we also have other hardware vendors on which our solutions can work. And finally, the architecture of all of those solutions is really scalable. We can start with, let's say, Big Cloud Fabric working on 2 racks. So there will be like 4 to 6 switches in this case. We can grow easily to 10 racks, 20 racks, 30 racks. So as you grow, you easily can increase the scale of those deployments. The same 3 principles are used by companies like Google's, Facebook's, Microsoft. They are not purchasing the traditional, the legacy networking solutions anymore because they just don't scale. They can't automate them as easily. They're just too cost prohibiting as well. What they do is they purchase open networking hardware and put their own software on top of those devices. But they have an army of software engineers in-house who can develop those open networking solutions for them. We know that not every customer has enough software engineers with networking knowledge in-house, and this is where we come in. We deliver those solutions for such enterprises, for such telcos. All right, and now this is the drawing I mentioned. Hopefully now everything will be clearer. Let's go one by one from the left side. When the traffic is entering your data center, over here we can help you do security chains. Maybe you want to decrypt your traffic and analyze it before you allow it in your data center. Maybe you want to have 2 other devices that should look at that traffic while it's decrypted before we allow it into the data center. So we can help you interconnect all of those devices. We can create security chains, service chains for different types of traffic. It will be different security chain, so you can optimize the way you're using your tools. Once the traffic is allowed into the data center, then we have our production network. This is where we can put Big Cloud Fabric as the data center fabric. Leaf and spine architecture managed by the set of controllers, and any workload can work on top of us. We can integrate with OpenStack, containers, VMware, Nutanix, but we can be a solution that just interconnects any of your physical or other virtual environments. And finally, when you want to monitor your production network, you would have tabs or span ports generating copies of the packets for some other tools to look at. And to optimize the use of those tools and to help you with the scale, we can insert our big monitoring fabric in what we call the out-of-band mode. Over here, we can do filtering of the traffic, some modifications of the packets. We can create PCAPs of your packets. Eventually, everything will go to the tools which do the final monitoring of your data center. So this is how you can implement our products inside your data center. Any questions here? All right, moving on. How would this entire open networking thing works? Where's the software? Where's the hardware? So let's start from the bottom. So on the bottom of the network, we would have open networking hardware coming from Dell EMC. By default, those switches are equipped with ONI bootloader. This is the provisioning layer. This is something like Pixie boot in the world of servers. It just helps us automate the process of switch bring up. The only thing you need to know about this switch is the MAC address of management port. You configure it, add the controller, give switch a name. Within 5 minutes, this switch comes up. We install Switchlight operating system. We put the configuration on that switch. For you, it's like handoff. You can drink a coffee in the meantime. After those 5 minutes, you have brought up 1 switch, 10 switches, 100 switches, depending on how many you connected to power at the same time. And you have your fabric ready to start operating. So it's much faster to deploy this type of solution compared to traditional legacy approaches. And now, how do we translate, how this entire architecture of leaf and spine translates into what you might be more familiar with, like chassis-based solutions? So we have a slide for this over here. In a traditional networking chassis, what you may have is a supervisor card, you would have line cards, and you would have backplane, which interconnects all of the line cards. In our architecture, those elements are kind of similar, just the form factors are different. So instead of supervisor cards, you have controllers. They can be deployed as virtual machines or as dedicated hardware appliances. They work in active standby mode. Then backplane, this is our spine switches. Their role is to interconnect other switches. Those other switches are leaf switches. Those are top-of-rack switches, basically. They are grouped in pairs for redundancy. They're like line cards in your chassis. So this is the place where we are connecting all of your workloads, your servers, your storage, your other networking devices. And I hope by now you know that you manage it all as if it was one logical device for you. One big switch, and this is exactly how the name of our company came up. You manage 10 or 100 switches as if it was one logical device for you. You don't really log in ever to any of those physical switches directly. Everything you do at the controller. You want to add a new VLAN inside your data center, okay, you do it at the controller. You want to troubleshoot, see how the traffic is being forwarded between 2 servers. Again, you do it at the controller. You don't need to log in to any of those switches. It's much more easy to manage compared to legacy approaches. There are lots of customers here in the region and worldwide already deploying our solutions. I'm going to maybe mention the few biggest ones, but don't get scared. We are also really cool when we're working with smaller or mid-sized companies. So the biggest ones would be Verizon and T-Mobile. They are telco operators in the United States, and they're using Big Cloud Fabric as their network function virtualization infrastructure. Then something closer over here in France, we have Ministry of something, and one of the public sector companies, ministries, they're using Big Cloud Fabric across 2 data centers. In Poland, we're working on a tender, and the customer will actually buy both of our products. That's the plan, both Big Cloud Fabric and Big Monitoring Fabric, to have data center networking plus monitoring in 2 data centers. Speaking of Big Monitoring Fabric, I think the most important customer, because it was the very first one and the one who pushed us to develop Big Monitoring Fabric, is Microsoft. They wanted to have a way of monitoring their data centers. Those are actually Azure data centers. So they came to us like 8 years ago, and they asked us, hey, can you build, since you're doing software-defined networking, can you build this network packet broker kind of solution just to collect those copies of our packets and deliver them to our tools? We don't need anything like too crazy. It's a simple solution after all. We did it, we developed that product. Over time, we've been implementing more and more features, so now it's much more advanced. And it was a very good decision for us to listen to Microsoft, to what they actually wanted, and build that product. Now both are selling really well. In Poland, we have already a few customers using Big Monitoring Fabric. So there's a bank using it. There's, for instance, some e-commerce platform using it as well. So there are good implementations here in the region, really, really close by. We have customers in Middle East, in Japan, most of the customers are still inside US. That's where we see the biggest market traction. And why would you look at solutions like this, even if you don't really care about the technology itself? Well, you would be saving lots of money, that's for sure. I don't want to focus on it because I feel like I want to get your technical interest. But if we were to look at savings, first of all, open networking hardware is priced really competitively, and our licenses, our software is priced really competitively. So even on the list price level, you would see a difference between our combined solution with Dell EMC and some legacy vendors' solutions. So that's first thing. Then we're saving your time. To implement, to deploy this type of installation, you need hours, maybe a couple of days if it's a really big data center. It doesn't need to take 2 weeks or a month to install your data center. Then when you want to deploy new applications, when you want to reconfigure anything inside your data center, it takes a few clicks. You do it within minutes. You don't need to touch hundreds of different devices to reconfigure the data center. When there are some issues, something's not working, in our controller you see it, everything clearly, what's not working, what's working, and I hope I will show you during the demo that we have great troubleshooting capabilities, so we're again saving you time. With all of those, maybe you can have some members of your team not focus on managing mundane exercises inside your data center. Maybe they can focus on some cooler integrations, containers, hyperconverged infrastructure. You don't need to have many people managing your data center because it will be much easier. I have one customer in Dubai who is using Big Cloud Fabric now across 4 data centers. So it's basically 4 Big Cloud Fabric installations. There's pretty much one guy managing it all. They can log into each of the controllers from their management network. They can do all of the configuration changes sitting at one desk. So those are the type of benefits that you would see when you go for a solution like Big Cloud Fabric. Everything clear so far? All right, so what I'm going to do now is go through a few more slides, and I want to show you some demos for Big Cloud Fabric. And then we're going to come back to Big Monitoring Fabric, okay? So for Big Cloud Fabric, I hope the entire architecture, at least some parts of it, are kind of clear. You have spine switches, you have leaf switches, you have controllers. A few more cool things. When we integrate with solutions like OpenStack or containers, we expand our footprint. We can do the networking for your for your virtual network as well. Is anybody here looking at OpenStack or containers? Some of you are nodding your heads. So yeah, okay, feel free to reach out to me. Maybe we can discuss in more details sometime later. But what I'm just trying to highlight, we can have our own virtual switches deployed on the compute nodes. We can manage them through our controllers, like we would be managing our physical switches. We have full visibility across physical and virtual environment. We can show you everything from the VM when it connects to your virtual switch inside the compute. We can show you the entire path of the traffic. For VMware, we also have good integration, lots of automation, lots of visibility, and I hope inside the demo, during the demo, I will show you all. Lots of automation in each of those integration types. Let's say you have your virtualization environment already integrated with Big Cloud Fabric. It can be VMware, it can be OpenStack. And let's say, okay, your needs are increasing. You want to add new workloads. You want to add a new compute host into your fabric, into your network. Well, you just register it at your controller of the virtualized environment and just connect it to any of our switches, any port. We don't care. We will discover it automatically. There's no way for you to make a mistake. Just plug it in wherever you want. Well, ideally, if there's a pair of leaf switches and you have 2 ports on your server, well, one goes to each switch. And that's it. We take care of provisioning the networking. When you put your VM on this new host, we will make sure networking configuration is there. When you move your VM from one host to another, we make sure the configuration is following So everything is happening automatically. There's no way for anybody to make any mistakes while reconfiguring. It doesn't take long because it's real-time reconfiguration. As you're moving your VM, we get notifications. Let's say from VMware vCenter, we get notifications that, hey, this VM is moving. Our controller will be informed. We'll be reconfiguring your network. Done. You're tearing down your host, you're disconnecting them, we're removing all of the configuration, which is not needed anymore. So it's really, really simple, and you can relax. We got your back. You can focus on some other things. All right, so all of the integration types that we can have right now for Big Cloud Fabric. VMware, this includes vCenter, NSX. I know some of you are interested in OpenStack. Is anybody looking at VMware solutions? So, okay. If you ever are, we're a great underlay. We're great physical connectivity for VMware. Well, in VMware, you have your servers, but you need to interconnect them somehow. This is why you would need a solution like Big Cloud Fabric just to interconnect all of your devices. The same goes for OpenStack. We're a great underlay with our, what we call the physical plus virtual integration, where we do the virtual switches. Brings you so many benefits. Containers, Kubernetes, Mesosphere. So if anybody's interested, I can give you more details. Hyperconverged infrastructure, so we have Nutanix, KIO, vCenter for VMware. And finally, if you're not using too much of virtualization or you don't want to integrate it with us, you don't want all of the benefits of automation, we can be just a really great underlay. Not integrated, we'll just be providing you with great visibility, lots of Big Cloud Fabric own benefits, which I will show in the next slide. So for any other technology, any other physical environments or virtual environments, we can easily interconnect them all. When you have multiple data centers or you want to migrate your existing infrastructure into Big Cloud Fabric approach, we have workflows for it. We have options to interconnect. I don't want to get into too many details maybe over here because that would be really technical, but we have really good workflows to help you migrate. We have great solutions for interconnecting multiple data centers. What we will be releasing end of this year is Controller Director, which will be a higher hierarchical controller to help you manage multiple data centers from the very same console. So we'll have one console to manage multiple data centers. Right now, each of your locations would require a separate set of controllers, but we're improving that. Okay, and what are the good benefits of Big Cloud Fabric itself? Well, first of all, configuration is really easy. We have simple config concepts, tenants and segments. They would translate to something like VLANs or VRFs in traditional networking. Really easy to get. We have great troubleshooting. We have great visibility. So I will show you that in a demo. API, REST API, that's the main interface to our controllers. We have great GUI, we have great CLI, but there are only clients to our API. That makes it so much easier to integrate with any other solution. So much easier to automate any configuration changes through some external script or through some external orchestration. You have one place where you see it all, where you configure it all. With few clicks, you can bring up entire environment consisting of tens, dozens of switches. The same goes for bringing up new servers when you're starting doing automation. Troubleshooting is really easy, and something which I really strongly want to highlight is upgrade, because this is a really serious issue for data center. In traditional approach, where you have those devices managed separately inside your data center, you need to usually schedule some outage window for some of them at a time. You usually don't upgrade everything at the same time, so it's so much overhead for you. You need to spend so many nights in your data center upgrading those devices. For us, it's a totally different approach. First of all, upgrade takes like 15, maximum 20 minutes. We upgrade entire data center at the same time. And as long as you have all of your devices connected in a redundant way to our switches, then there should be no traffic disruption during the upgrade. So it takes 15 minutes and it causes no service downtime for you. So that's a really, really good benefit. And I've been testing it multiple times with customers during POCs. Everybody's impressed with the way we do our upgrade. It's all orchestrated by the controllers, fully automated. You seriously need to run 6 commands in our controllers, like 3 on each of controller, and 15 minutes later, your entire setup is upgraded. Our solutions are very flexible. Open hardware, open networking, that gives you flexibility by definition. We scale out easily. We can have multiple different environments running on top of us at the same time, integrated with our controllers at the same time, and they will be not troubling one another. So you can have multiple environments. You maybe have your testing, you may have your dev, you may have your production network, all running on the same switches. We will just isolate them from one another. Any workload can run on top of us, basically. All right, so API, I already mentioned it. Okay, one thing I would like to highlight, resiliency. If you follow our guidelines to how do you build the fabric, meaning you have pairs of leaf switches, you have at least 2 spine switches, you have all of your devices dual homed, connected to both of our leaf switches, so they're redundant, then we have great resiliency. And we have Chaos Monkey test results to vouch for us. Chaos Monkey is a test which was developed by Netflix, and they developed it just to test the resiliency of their data center. What this test does, well, in an automated way, it behaves as if you let some crazy monkey inside your data center, and it started plugging cables, rebooting devices, causing chaos in the data center. So there's a script that reboots some switches, shuts down some links, does failovers between controllers. During this chaos, we're measuring some performance metric of the network in the data center. Let's say file download from one server to another between like 2 racks. You're just checking how much time it would take for this download when all of this chaos is happening. You remember this value, then you shut down your script, everything's idle, peaceful and quiet, and you do the same test. You do the same download, transfer between servers. You measure the time again. Ideally, you should have the same results if your solutions are really resilient. And maybe it's not visible here, but that's what we got in our test results. The values of those performance metrics were the same in chaos and stress conditions and in idle and the baseline conditions. You can read up the test report on our website. It just proves that, well, you can go and do some crazy things inside the data center and your networking will still be working. So that's actually what I was testing in the POC that Emil mentioned. Basically, we're doing something on our consoles, just having some pings flowing between 2 laptops connected to our network, and one guy went into the data center. We didn't know what he was doing, and we see the pings are all going through, working fine. And then like 5 minutes later, that guy comes back, all happy and trying to figure out, okay, did we see anything or did anything happen? Because he started replugging the cables, like disconnecting some spines from leaf switches, changing the links, whatever. He was doing some crazy things inside the data center. And for us, it's like, no, did you change anything? Did you do anything over there? No, it just proves that the solution is resilient. You can have lots of different failures inside the data center and we would still work fine. Okay, I'm not sure if you are interested in network function virtualization. This is pure telco use case, but if you are, then we have great reference with Verizon in the United States. They are using our Big Cloud Fabric on top of Dell equipment. This is all orchestrated by Red Hat OpenStack, and that's how they're building their network function virtualization infrastructure. All right, this is containers. I didn't see much interest for that yet. This final slide shows that, okay, you can have so many different environments running on top of Big Cloud Fabric at the same time, and you'd still be fine. They wouldn't be troubling one another. I think I hope I mentioned all of those benefits, how how many things we automate, how much your life is becoming easier when you use a solution like Big Cloud Fabric. All right, and now let me show you a quick demo of Big Cloud Fabric, and then we'll come back to Big Monitoring Fabric. Okay, my VPN got disconnected, so let me just reconnect. Give me a second. Okay, I see that the quality is not the best, but I hope once I will be walking you through the elements over here, you'll get the idea. So what we're looking at right now, that's the main landing page of Big Cloud Fabric. And over here, we just want to show you in a snapshot if everything's okay with your system or not, and what are the main performance metrics here. So you would see is like how many switches you have configured, how many tenants and segments you have configured and such. Then you have some details about your controller, memory, CPU utilization and such. So if there's something overusing here, then you can see it immediately. Then in those panels, we have memory utilization and CPU utilization for your switches. So each of those boxes here represents one of your switches. Everything looks good. If there something was overusing any of those resources, you'd like have the blocks growing, changing color into red. So it's easy to get if something's not behaving properly. Then we have some statistics for the traffic, and we are grouping them per segment, per tenant, and per switch interface. Segment is like VLAN, tenant is like VRF inside, compared to traditional configuration. Okay, when we click on Fabric page, we're being brought to this view. Over here, we show you the overview of the system. So we have controllers, we have spine switches, and we have leaf switches grouped in pairs. This is all kind of interactive. I just can't find. Okay, even if you hover over some port on this little icon of the switch, we would give you some more details on this. Just like the cool thing, then we can show links and show you how all of those devices are interconnected. If there was anything wrong with the physical connectivity between those switches, we would show you. Oh, okay, I got disconnected again. There was like a Fabric summary, which you may have seen over here. There were like 280 something warnings. If there was something seriously wrong, you would see also errors. So let's say if you don't have a connection between some leaf switch and some spine switch, then we would flag it as an error, and then it's easy for you to see it because it's just here with some red background. Okay, now when you click on some specific switch link, then you would be brought into this page. Let me move it back a little bit. Okay, so you get a view of your switch, and it should look exactly the same as you would see the physical device inside your data center. So those lights are lit the way they would be on a physical device. Again, you can have some more details here. If you want to, you can just play around with it. It's kind of like interactive. But there are lots of good details about that switch here, not only the visual trinkets. Okay, one of the power units is not present, so that's something you may wonder why some interfaces are not grouped in pairs. So that's another thing which you may want to look at. Lots of good details, properties of the devices, actions you can take for this device. What's interesting is beacon. When you trigger this command, the switch, the physical one, would just start flashing all of its lights inside the data center. So if you're here sitting in your office, you have somebody, some technician helping you in the data center, you can point them easily to what switch they would be working at, which links they should be reconnecting, just to help you manage it even remotely. Lots of other options available. And then there are other good tables showing you some stats, showing you some environment details, list of all of the interfaces, list of virtual switches connected to it, and so on and so forth. So I don't want to go through all of them, just you have all of those details about that particular switch here in this one place. Okay, then next. Let's go back here. I told you how easy it is to configure a new switch, so let me just quickly show it to you when you want to add a new switch. Okay, there's something wrong with the connection again. Is there any limit on Wi-Fi time that I can be connected? Because after like a few minutes it just drops. No? Okay, it's working again for a little while. Let's enjoy. All right, so but this one opens. So you just type in your MAC address of the switch. You give it a name. You select a role of that switch in this product. That's spine leaf or none. Some other details, but well, this is it. If this switch is already powered on and connected to the management network, once I submit this configuration, the switch will just start talking to the controller, get its software using the ONI bootloader, get its configuration in 3 or 4 minutes. It's ready to go. I won't change it because I'm actually working on a live setup in our headquarters, so I don't want to mess things up. All right, so let's go next. When you click on logical here, you would get this overview of your configuration. Those brown boxes, they represent your tenants, your VRFs. This blue box, this is special tenant, special VRF, called system tenant. It's used for interconnecting other tenants. Just remember about it because we will use it in the demo later. Then when we have something called external, we will just present it slightly differently. The goal of this tenant is just to interconnect with some external networks. And this is all interactive. You can see what's connected to system tenant and what's not. You have a list of all of those elements here. Okay, so maybe I will just quickly show you, hopefully the Wi-Fi is still working, yeah, quickly show you how easily you can provision your networks. I'm using this simulated environment. I have 2 servers, R1, H1 and R1, H2, connected to 2 of my leaf switches. I just want to put them in the same network, in the same VLAN, so that they can start pinging each other. Okay, this is closed. Okay, so I'm just going to trigger the ping. I'm logged into one of the servers, pinging the other one, nothing's going through. First thing that I would have to create is just to provision port groups, lags, for those pairs of links going to our servers. So this is actually something I already did, R1H1 and R1H2. You can see the member interfaces going to each of our leaf switches. Creating interface groups is really, really easy. You just select on which pair of leaf switches you're working, and you just click on which interfaces should be placed in that lag and in that port channel. And you give it a name, and you're done. So now the next thing which I would have to do is put those 2 interface groups inside one segment in a given tenant. So let me just open the tenants page. Okay, so I'm creating a tenant. I'm creating a VRF. Sorry, not this one. Inside this demo tenant, I'm going to create a segment. Okay, and now I go into the details of this segment and just add the membership rule, saying, okay, those two lags that we have created, they belong to this segment, so they should be seeing each other as if they were connected to one logical device. So that's one of the interface groups. That's the other interface group. Okay, and let's go back to the ping page. Voila. We can start seeing the pings going through. So now, okay, I know this is a very basic example, but within a couple of minutes I have created basic network. So now you want to create more of those. Okay, you keep on repeating those steps. You want to create something more advanced. Well, those options here are still very simple, so it doesn't take much time to create this type of network. Now let me show you the capabilities of our API. Let me just, okay, take this thing. So now I'm going to show you pretty much the same thing, but done through our script, through our API. As you may see, the CLI is kind of industry standard, so you should feel very familiar with it if you are used to switches and routers. So now I'll do show run, and we have this tenant demo. Okay, I'm just going to remove it, and at this point, the pings have stopped because I've removed the networking configuration. Now I have a very simple script, and don't judge my coding skills, I'm not a software engineer, but basically I've created like a very simple script, and I'm going to use a few functions: create tenant, create segment, and add membership rules for those interface groups into that segment. So basically I'm going to do the same as I've just done manually. Okay, so that was done, and voila, the pings are again going through. So even without manual work, if you have your scripts, if you have some software engineers in-house, they can help you automate this type of configuration changes. So not even minutes, you can do changes in your network within seconds. All right, now coming back to GUI demo. All right, the next thing which I want to show is test path. This is our troubleshooting tool. What it does, it's similar in function to traceroute. You select two devices in your network, let's say two servers in this case, and you want to verify connectivity between them both and see, okay, is it supposed to work or is it not supposed to work? If it's supposed to work, maybe there are some physical issues that you want to nail down. So to trigger test path, you just select source and destination of the traffic. For me, these are two physical servers. One has IP like this, the other has IP as follows. There are members of different tenants in different segments. First thing which I can do is to run a simulation. And when you see the simulation results, you see hop by hop how the traffic is being forwarded from logical perspective. So we see that the source is in tenant QA segment, ZTN test. It goes through logical router in this tenant, through tenant system. Remember, that's the one that I mentioned for interconnecting other tenants. Goes into tenant servers, segment build servers, and this is where it finds its destination. And as you may have seen, while I was hovering over different elements here, you just have details of what ACLs are being hit, what rules we are using to forward or deny this traffic. So it doesn't matter if it's like one switch, multiple switches. Here we're looking at the logical perspective, logical configuration. For us, everything looks good. It's forwarded both ways, like reverse and forward results are passed. The next type of test which we can run is more physical focused. What we do is just click on test, And for 30 seconds, we are monitoring the packets going through. So over here, the requirement is that you actually have those packets, in this case, ping packets going from one server to the other, and we will just be monitoring them. I've run this test already, so I'm just going to show you the results. And the result is as follows. We see that the packets are coming in on Ethernet, what is it, 16 or something, on lab leaf 2A, I believe, using those interfaces to go to spine switch, then finally to another leaf switch, and using interface group to go out to the final server. So this is the type of visibility that we're giving you. If you have some issues with your configuration, the simulation would already tell you, okay, you have a rule blocking this traffic, or maybe you have forgot to configure some IP for the segment. So anything you misconfigured, or maybe incidentally or accidentally blocked, you would see it in the first step. If there are some physical issues, you would see it here because we count all of the packets that we see on each hop. You see that over here, everything's matching. We had tests running for 30 seconds. Pings were like 1 ping per second. So we have all the packets. If maybe there were some issues with physical layer, you might just see the counters are off. And now just very quickly, this type of visibility when we have physical and virtual networking. So remember like OpenStack and containers where we have virtual switch in the environment. So I'm going to use the same, some other devices. My source, in this case, that's a virtual machine running in OpenStack. My destination, that's one of the physical servers. It's actually the same destination as in previous test. Over here, the results of the simulation are a bit more verbose. You have some auto-generated, very user-friendly names from OpenStack. You see that this OpenStack endpoint needs to go through network address translation, to go into public network through our external tenant, go into system tenant, and finally, oh, sorry. Okay, I can't scroll it down. I don't know where that piece is. But eventually, we're going out to the tenant build server, tenant servers, segment build servers, back into this physical device. And again, on each hop, we see what rules. In this case, it's always default permit that we're using to forward or deny the traffic if it's denied. And then again, you can run the physical test, which over here spans into the virtual environment as well. So I'm just going to show you the results. And as I announced earlier, our visibility starts at the virtual switch, at the virtual interface of the virtual switch. So the main point over here is you troubleshoot easily. You have one place where you see everything that's happening inside your network. If your configuration is bad, you can validate it here. If there's something wrong with the physical networking, you will run the test and you will see it over here. So that's what I'm saying. It's like troubleshooting is much easier compared to legacy networks. You don't need to check each of those switches or routers separately. You have one view across your entire data center. Okay, there was not many people saying that they're interested in VMware integration, but just to give you an idea, when we integrate with vCenter or NSX, just a few clicks to do this integration, and then we accept for lots of automation. We provide you great visibility, so we see what servers are running inside your VMware environment, what virtual switches are configured on each of those hosts, how your VMs are being connected, through what port groups, to what virtual NICs, on what host it's being configured. So you have a really good view across your virtual environment, looking at it from the networking console. Then if we scroll down, more details on servers, on virtual switches, on physical connections, and what I want to go into is like when we have integration with NSX, we have even nicer view how your VMs are connected to your logical switches inside NSX, how it translates into hosts, into servers, and how it's all connected to our physical switches. So you get a really nice view across those two environments. And just FYI, we also have a plugin to VMware environment, which from the plugin, it's in vSphere, your virtualization admin can run test paths and can view our configuration. In this case, when your virtualization admin says, okay, why is this ping between those VMs not working? they can check, troubleshoot themselves. They have the view inside the networking beneath the solution. All right, one more element which I want to show here for Big Cloud Fabric is our analytics module. When you go into visibility, analytics, you would open up this console where we collect. This is a place where we collect logs, statistical information about the entire solution. This is the main landing page, and it shows you main events across, well, the last 24 hours. There was nothing really interesting happening inside the network, so no events here, but there are lots of dashboards which we can look at, and I've opened a few of them. Those are all of the events happening across some time period, across all of the devices. So you would have controllers, you would have switches. This is all very interactive, so we can select some piece of the chart, and then all of the other would be updated to reflect what you're filtering on. Elasticsearch log/Kibana. Maybe some of you guys are familiar with it. Next dashboard, that's CPU and memory utilization. These are historical data, obviously, for your controllers and for switches, so you can see if everything was behaving or maybe misbehaving. And over here, we're looking at last 7 days. So you don't need to maybe monitor everything real time. Obviously, it's advised, but if you notice that something had been happening in the past, this is a way to just take a look at it and see what was going on. This is a dashboard with traffic rates and like per segment, per tenant, per switch interface, and this is all interactive. So you can just filter on the specific statistical information that you want to see. All right, and I think that was the demo that I wanted to show for Big Cloud Fabric. And now we would go into Big Monitoring Fabric, unless somebody maybe has some questions at this point. Okay, I guess no. So let me open up the presentation again. All right. Why would you need a solution like BMF in first place? You want to monitor your data center. There are so many different threats these days, especially. Every few weeks or few months, you hear about big cyber attacks, some data was stolen, some security breach. You want to be able to monitor this type of events and see them happening and maybe stop them, or at least be aware of something which was happening. That's really important in the context of GDPR, which is like all over the place right now. It went live like last week, no, I think last Friday. One of the things which you need to be aware of is all of the data breaches. If somebody breaks into your data center, steals your customers' data, you need to notify those customers within a few days. And now, if the breach was stealing data only for 5 customers, and you know it only affected 5 customers, and you're, let's say, a bank, you can notify only those 5 customers. Hey, your data was stolen. But let's say you know there was a breach, but you have no idea whose data was stolen. You need to notify all of your customers that there is a potential threat that your data was stolen. So look, even at publicity, you can save your brand if you know whose data was stolen. You don't need to inform all of your customers. You only inform those selected ones. So this is where solutions like BMF are really, really useful. You want to monitor every place in your network. You want to have multiple tools looking at the data in your network, at the packets in your network. But as your data centers are growing, it's becoming more and more difficult to monitor everything. I would say that the very basic troubleshooting tool like this would be your laptop with Wireshark connecting to a span port of your switch, and you're just downloading some packets and you're looking through them. But this is like one tool and one switch at a time. Now imagine you have 20 switches in your data center, and you have 20 tools that would like to see those packets. It might be Wireshark, it may be some Riverbed, FireEye, something that's looking at the performance, something that's more advanced looking at security, something that's doing analysis of the performance of the network. So see, you have more things to monitor and more tools that you want to deliver the traffic to. And you can't plug in like one device to one tool because that makes no sense. You want to have a way of collecting traffic from those copies of the packets from all of your devices, and you want to have the flexibility to what traffic goes where. Okay, some of your tools may be interested in only in TCP traffic. Some of the tools may be interested in only specific subnet, some other protocols. You can filter the traffic and deliver to the specific tools. So this is where solutions like Network Packet Broker came into the picture. This is the reason why they were built, just when you were wanting to monitor more places in your network and having more tools look at that traffic. But the traditional solutions, I would mention like Cisco, Ixia, Gigamon, Ixia, NetScout maybe. They would be having those chassis-based solutions, which is something similar to box-by-box approach in managing your data center, like switch by switch, network packet broker by network packet broker. And they were really, really expensive. And if you start having more of them or more data centers to monitor, managing it all, that becomes a nightmare. So then, thanks to Microsoft, we have built this solution, which is what we call the next generation network packet broker. It's like security-focused solution where we create a fabric of switches which gives you lots of flexibility. We can start with one switch. We can grow into a number of switches depending on how many tools you have and how many devices you are monitoring. But the point is, this is a really scalable solution, really flexible solution, and costs of open networking hardware, our licenses, it's an open solution. So you would see lots of benefits even on the cost side when you're installing a solution like this. You manage it all again through a centralized controller. In this case, it even can span across multiple data centers with one controller. I'm going to go into details slightly later. But I trust that you at least get the idea why this type of solutions are needed. And now let's go one by one. I'm going to describe all of the elements that we can have in big monitoring fabric. Starting with your production network. This is where the copies of your packets are being generated. You have taps, you have span ports. Everybody understands those terms? Tap is like a mirror on your optical link, just takes out some of the lights, some of the power of the light, and reflects it into a third tool. Span is just a port on your production device that basically sends out copies of the packets. On the other side here, you have your tools. Lots of logos that you can look at. Some of them may look familiar, some of them maybe not. We're totally agnostic. We would work with any of the tools. And you want to have the flexible way of interconnecting your taps and spans and all of those tools. You want to be able to filter the traffic. And this is what we are doing already on our switches. Any filtering, layer 2, layer 3, layer 4 header fields, deep packet matching, all is done on our switches. This can be one single switch. It can be 3-tier architecture, something like leaf, spine architecture. We would call those filter switches, core switches, and delivery switches. So depending on the scale, we have different types of architecture here. Those switches would filter the traffic and deliver them to one tool, all of the tools, select specific subnets, specific protocol, deliver to selected tools. So that's the basic operations. If you want to process those packets in some way, we can connect service nodes. We can connect third-party service nodes, which are not coming from BigSwitch. And one example I would say here is offline decryption of your packets. Right? When you have a copy of your packet, you want to decrypt it. We don't currently have a way of doing that, so we can connect some other tool that would do it for us. And the way it would work, we would receive the copy of your packet through our switches, we would send it here, it would get processed, whatever this device is doing, we would receive it back, and then we send it to the tools. Simple. And this device can, well, those can be any devices as long as they can process your packet. But what we highly recommend is our own service node. This is additional server with our software that we connect to our switches here. This is all managed through the same controller, so for you it's still one point of configuration. On this type of service node, we can do additional packet optimizations before we deliver them to your tools. Let's say some of your tools want to see only the header of the packet, not the entire packet. So our service node can cut out the payload and deliver only the header to your tools. Those tools are actually kind of expensive usually. So if you can optimize the way you're using it, you should do it because you're going to save money. When you're monitoring multiple points in your data center, you may see the same packet across multiple devices or across multiple links. If your devices don't need to see all of those copies of the packet, we can deduplicate those packets. And instead of sending 10 copies of a packet, you only send 1 copy of the packet to your tool. So there are lots of good services here: packet slicing, packet masking. That's again something which might be useful for GDPR. We can mask sensitive data inside the packet, like credit card number, some national identification number, and such. Header stripping, matching on regexes. We can generate net flow. We can do software-based timestamping. GTP correlation, that's for telcos mostly, and UDP replication for anybody. So that's our service node. Let me maybe open up. Okay. Another type of service node which we have introduced very recently is a recorder node. Again, a server with our software continuously recording your packets. Obviously, you can pre-filter them. You don't have to. You can save all of the traffic to those packet recorders. And this is this device which becomes very useful when we're talking about data breaches. When somebody breaks into your data center, but you have been saving all of those packets on the packet recorder, you can just go back in time, analyze those packets, see whose data was stolen, what exactly was going on, what the bad guy was doing, and you are aware, and then you can act accordingly. So this is really, really useful, especially for GDPR. When you have more than one location, we can put our switches also in your remote locations and monitor and manage it through the same set of controllers. Over here, we can span entire country. We have customers going across countries, even from the same set of controllers. We'll just put our switch connected to your taps or spans over there. If you have tools here, we will just deliver the traffic locally. If you don't have the tools in your remote location, we can create a tunnel, take it back to your main location, deliver to your main tool farm. Simple. You would have one place where you see the traffic from your entire network, let's say entire country. Talking about remote data centers, we are also working on integration with clouds, both public and private clouds. So we have integration with OpenStack and VMware already. We're working on integration with AWS and Azure. We will be putting our virtual switches there. We'll be integrating with the environment. And again, either delivering the traffic to virtualized tools in the cloud or taking it back to your on-prem location, delivering it to your main tool farm. Another cool element of this entire ecosystem is our analytics node. I will show it again in a demo. This is a place where we collect metadata about the traffic that we're seeing. Our switches are capable of generating S-flow samples. We can send them all to the analytics node, and from multiple locations or just one location, you would have an idea of what traffic is going through your data center.
Sorry to interrupt, but
yeah.
does this analytic node accept for example, net flows from other boxes also?
Yes. So, very good question. So it's tailor-made to work best with this environment, but those are standard S-flow and net flow receivers as well. So we can have other feeds sending data to here. It's not only S-flow, net flow. Actually, we have a number of trackers installed on our switches. And every time a DNS, DHCP, ICMP, ARP packets are noticed by our switch, they would send a notification to our analytics node. And this is a way in which we can track all of your DNS servers, all of your DHCP servers. you can easily notice that some devices are trying to get information from some rogue servers. So again, really easy to discover that there's something misbehaving in your data center. Analytics node is one of the ways where we can access the data recorded on the packet recorder. We can do some flow analysis on the packets which are recorded here and let's say tell you what applications are visible in the data center. If we have some Netflix traffic, we will tell you it's Netflix, Facebook, WhatsApp, and stuff like that. So those type of features are very, very popular in Middle East. They like to monitor their users. They want to know what the users are doing. And we actually have one of our biggest installation of big monitoring fabric in United Arab Emirates. One of their telcos is really keen on this solution. Okay, I think I have covered most of those devices. Maybe some more highlights here. Controllers are, again, active standby, something which I maybe haven't mentioned, but it goes for both products. If for whatever reason both controllers are down, nothing happens to the switches. They have all the forwarding logic already installed. So both of your controllers get broken, your traffic will be flowing just fine. That goes for both Big Cloud Fabric and Big Monitoring Fabric. You will not be able to introduce any configuration changes, because for this you do need the controller, but otherwise whatever is configured, it will just keep on working. API, intent-based, role-based. Okay, this is actually kind of important when you have, let's say you would have multiple teams monitoring your data center, and you would want to give access to some specific traffic to only one team, and the other team should not look at it, and the other team wants to monitor some other piece of the network. We can have this role-based access control, just give everybody their own privileges. Real-time and historical analysis, that's all in our analytics module. Switches, Dell EMC open networking switches, starting at 1 gig to 100 gig ports, so we can monitor pretty much any place in your data center. Really scalable, thousands of ports can be installed in one fabric, managed through one controller. Okay, our service nodes, you remember deduplication, packet slicing, and other features. They come in two flavors, depending on how much processing power you need, either 40 gig or 160 gig. Then we have this recorder node. Write speed is currently one port of 10 gig write speed. If you need more write speed, we can install multiple devices like it. It will just be creating a virtual, one logical recorder node, even though it would be separate physical devices. Analytics node. This is where we collect the metadata, and I will show you in a quick demo soon how it looks like in real life. You would have some performance views, some security views. We can actually do some alerting from here. We're just trying to develop those alerts on the base of customers' requests, and for now we have, let's say, notification about all of the new devices noticed in the network over a selected period of time. We can send you some email with listing, okay, those are the new MAC address which showed up in your network. Another alert that we can do is link utilization. With this, you can monitor bandwidth utilization inside your production network and see that, okay, maybe this link is close to being overutilized, so maybe let's add another member in the leg. SFlow, NetFlow collection, capacity planning, that goes down to the bandwidth monitoring. Okay, and some use cases now, examples. So I want to say this is basically what Microsoft is doing. What we have here, those boxes, those are your racks. And over here you have top of rack switches. From top of rack switches, we are taking span links and having copies of the packets delivered to our filter switch. Sorry about the bad quality, but I hope you're understanding what I'm saying. So for each line of racks, you have some filter switch. You have other places in the network, For them, we would also have some other filter switches, a few core switches, and finally delivery switches, where your tools are connected. So literally, you can take any traffic from any place in the network, deliver it to any tool. Simple. And Microsoft is monitoring their Azure data centers. I think there are like 20 or 20-something data centers worldwide being monitored by them in this way. Telco operators like our solution, the very first ones to implement it were Japanese customers, Japanese telcos. And if you have ever worked with Japanese customers, you would know that how much attention they put to quality of the products. They would not install anything if they have not spent 6 months testing it internally. So that was a great statement for the quality of our products, because pretty much all the biggest telcos in Japan installed Big Monitoring Fabric. Something closer, we have a customer here with Dell in Austria. One of the telcos is using us to monitor their 100 gig data mobile network on some core links. And obviously, Middle East, they also like it. Soon we will be releasing a case study with one of our customers who's not too far from here. It's Base Farm. They're an ISP based out of Norway and Denmark. They have 2 data centers, one in each of those countries. And that's what basically they're doing. They have one switch in one location, another switch in the other location, and they have one set of tools. So they just tunnel the traffic from one location to the other to be able to see all of the traffic from both data centers in the same place. That's why they were wondering if they should go with 2 IDSs, let's say, one in each data center, or have Big Monitoring Fabric and one IDS in one of the data centers. They went with this approach, and hopefully within the next couple of weeks on our website you will be able to read the case study for this. Okay, that was Big Monitoring Fabric out of band. So everything that we've been talking about is the mode of operations where we work on the copies of the packets. Now, inline architecture. Why would anybody need this type of inline architecture in their data center? Well, to secure their networks. I've seen different approaches in customers' environments, how they secure their data center on the perimeter. They would have some firewalls, IPS, maybe some proxies, whatever, connected in a chain like this, one to another. What's wrong with it? Well, all of the traffic needs to go through all of those devices. We're not using them in optimal way. Some of those devices may be interested in only some specific protocols. Why would I want to bombard them with all of the traffic from all of other protocols? Those devices are expensive. You do not want to not use them in an optimal way. Changing any configuration, or if anything goes down, anything breaks, basically you have outage in the network. Our approach is different, and I really believe it's much better. We just insert our switches, ideally a couple of those switches on redundant paths on the perimeter of your data center. You do it once and you're done, then you just connect your tools to our switches. And then you create service chains. You say, okay, let's say TCP traffic needs to go here and to the data center. Some other traffic maybe just wants to go through IPS, whatever. So you can have full flexibility which traffic goes where. Those switches can do filtering on layer 2, layer 3, layer 4 header fields, deep packet matching, so we can really optimize how you're using those tools. We can monitor the health of those tools to make sure they are actually up and running. Sometimes there are cases where the port of the tool is physically up, but the software has crashed. It's not processing any packets. We have a way of sending the health check packets to make sure that actually we receive something back to validate that, okay, the software is still up and running. If we don't receive the expected answer, we mark this tool as down, and we fail over to other instances of this tool. We can create span sessions from inline to our out-of-band infrastructure or some other network packet broker, whatever you may be using. It's totally agnostic here. Okay, and I think the most popular use case over here includes SSL decryption. This is not the way to go. I've seen some customers even doing, okay, for each of this tool, they would put a pair of production-grade switches just to interconnect it, and then another tool, another pair of production-grade switches to connect it all. They would call it lasagna architecture. That's not the proper way of doing it. I think this one is much cleaner. Our switches connected to your tools. The first tool that we would be hitting, that's the SSL decryption tool. We receive the traffic here, forward it to the decryption tool. Traffic comes back. It's decrypted now. We want to put it through some other security devices. If everything looks good, goes back here, gets encrypted again, and only then enters your data center. Some other traffic type might be going to other tools. It's fully flexible. Our switches are invisible to all of those devices here. If there's, let's say, LACP lag being configured between those two devices, those would be established between those two. They don't see us. We pass all of the traffic. We pass all of the packets. We don't talk any protocols. And what you are configuring is saying, okay, let's take traffic from this port, let's say traffic TCP, and send it here. And then once this traffic is coming back, then here's here. So you're working on ports. We're bumping the wire. We're kind of layer 2 service insertion. Nobody is aware of our existence here. And I believe this is a really good way of doing this type of insertion. Another use case, let's say your pipe is growing. Your connection to the external world can be 40 gig, can be 100 gig sometimes. But your tools can still handle only like 10 gigs worth of traffic. We can help you keep on using those tools. We would be just load balancing that traffic across multiple instances of your tools. So we're just helping you preserve the investments that you've made in the past. Okay, and I think that was all the slides for Big Monitoring Fabric. Now I will want to show a quick demo. If there are any questions, shout. All right. So this is, again, main landing page of in our GUI of Big Monitoring Fabric controller. You see that the GUIs they follow the same rules when it comes to design. You would have some statistical information about controllers, more information about configuration and the version of the controller, what is connected and what's configured, some global settings here for the entire fabric, some data about switch utilization. What's maybe worth noting, Big Tab, that's the out-of-band mode of operations. Anything relating to big chain, this is the inline. So those are the names that you would be seeing here in those menus. Fabric page would be very similar. You would see this view of switches. You would see the list of switches as we saw before, so I'm not going to show it. What I can show you is like the main configuration elements here. Over here, these are policies. What policy collects is it specifies from which ports we're taking the traffic in, so which spans, which tabs we're looking at here in this policy, to which tools we should be delivering this traffic, what traffic we should be delivering, so we can add match conditions. There are a bunch of shortcuts here, but the full window would just give you ability to specify like IPv4, ICMP, some VLANs, maybe some subnets if you're interested. That's for source, destination, port ranges. Deep packet matching is not currently enabled here, but that's also an option. So you specify this type of matching rules. You can add services, so those are our service node services or third-party services. You can specify that the packet should be recorded or not, and eventually you have this window with the summary of all of the configuration that you've done. You just apply it and the traffic starts flowing. So that's the most basic way of configuring policies, but there are some other options. You can do some drag and drop. Let me see, there's each of those big boxes that represents one of the policies, and now you can just drag and drop. Okay, I want this service to be added. I want some protocol to be monitored. I want to be using specific delivery interfaces. So, well, literally a child could manage it, so it's just so simple to use. In case of big chain, the inline, it looks very similar, but I think I didn't open any pages, so let's just skip that and go into the analytics module. So this is the place where we are collecting this metadata about the traffic. Let me move out a little bit. And this dashboard, this is the S-flow collector dashboard. We see what would be the top sources in your network, who's generating most traffic, what are the top destinations in your network, then how those samples are looking over time. Obviously, this is all very interactive. So we'll just be refreshing all of the other views. Okay, I actually didn't want to do that. Where are those filters? I don't see it. Let me just refresh this page because, well, we also have geo mapping of those public IPs, and and you can see that I'm even highlighted over here now on the maps. Quick, last 4 hours. Let's do it like this. Okay, so see. My dot is here. So, well, I'm logged into our data center in California over VPN. So you'll see that the biggest destination, that's our data center. But we're also seeing some traffic in Estonia. So, well, India, China, well, we have teams all over the world. So you can figure out where our people are based. But this gives you an idea where people would be logging in to your system or where your traffic is going. That's another thing about GDPR. You need to be aware of any traffic going outside of the European Union. That's one of the ways where you can actually see it. All of that data is available in tabular form as well. And if you are familiar with Elasticsearch, Logstash, Kibana, that's the 3 tools we are using to create those dashboards. You would know that they can be reconfigured really easily. You can create your own dashboards, create your own widgets, so you can tailor the views to your needs. Let's see, next view I believe, which I've opened, that's NetFlow. So our service node can generate NetFlow records, and we can collect them on our analytics module or any other third-party NetFlow collector. So you would see similar data with just more granularity here compared to S-Flow. Another thing, when we have this packet recorder integrated in the entire environment, you would also see what packets are being saved for your selected flow. Right now I haven't selected anything, but so I'm seeing all of the packets recorded. But let me see if I can add this one. Okay, I'm not sure if that's going to change much over here because that's actually a popular IP address. But anyway, when we have this packet recorder integrated from here, you can start looking at the data. So I have started filtering. I want the packets with source 8888. I can add some other filtering rules for destination protocols, from what ports I want to monitor the traffic. Then I can select to which of the tools I want to replay those packets. So I have them saved. I can send them to one of the tools. I can create a PCAP file out of them and download to your machine. You can look at it in Wireshark. Replay, that's clear flow analysis. I can run some analysis, and if there are some popular protocols involved, I would just show you, okay, the packets saved here, they are using those types of application. So this is a nice integration inside analytics, but pretty much the same is available through our regular GUI. Okay, I thought I opened some more pages, but I guess I didn't. Anyway, a few dashboards which are pre-configured, like tracked connections, flows. Then we have all of those trackers, ARP, DHCP, DNS, ICMP messages, all would be tracked, and you would see them all here on those dashboards. Then in the BMF network tab, you see stats, not necessarily reflecting the traffic. It's more like our statistics for policies, for interfaces, so more like operational data for our environment. And now the final thing I wanted to show you, we have a great online labs. You just go to labs.bigswitch.com, you register, it's automatically approved, and you can run your own environments of our products. So for Big Cloud Fabric, you have generic Big Cloud Fabric, BCF integrated with OpenStack, with VMware, something that's designed to do some exercises about automation. Then for Big Monitoring Fabric, you have out-of-band, you have inline, you have service node. So you can set up, and you get a virtual environment, your own sandbox. You have a script according to which you can go. We'll just guide you, okay, step by step, what you can do to arrive at some specific configuration, but this is all free for you to use. So you can try and break things, you can do whatever you feel like in those online labs, just to get the look and feel. So some of the things I was using here today, they were coming actually from the online labs. So that's I would say, the really, really good way of familiarizing yourselves with our solutions. And then if you would have more interest, then with our local partners in Dell, we are more than happy to conduct some POCs if there's enough interest. And I think that'll be all from me, unless there are any last-minute questions. If not, then, well, I'm here through the rest of the day. I have my business cards on me. If somebody's interested in talking some more details, I'm happy to exchange contacts and we can take it offline. So, thank you.